Okay, this is G.G.32. There's a few things we have to know first before we start these lessons. So I want you to take an index card out and I want you to copy this down. Alright, this is going to be about exterior angles of triangles. And there's a few theorems that we have to know. The first one is that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. We have to know that the measure of an exterior angle of a triangle is greater than either of its two non-adjacent interior angles, and that an exterior angle is formed by one side of a triangle and the extension of an adjacent side of the triangle. So fill it out just like I have. Put your last name here and 1 out of 2 here. On the back, here's an example of what that means. So in the triangle at the right, angle 4 is an exterior angle. You see this angle outside the triangle? Angle 4, that's an exterior angle. So what we have to know is that that exterior angle, which is out here, is equal, so the measure of angle 4 is equal to the sum of the two angles that are farthest away from it on the inside of the triangle. So the exterior angle, angle 4, is equal to angle 2 plus angle 3 on the inside of the triangle. When you see the words non-adjacent here, it's equal to the sum of the measures of the two non-adjacent interior angles. That's what 2 and 3 are. They're not adjacent to it. See, angle 1 is adjacent to angle 4. 2 and 3 are non-adjacent. Alright, so the sum of 2 and 3 equals 4. You should also know that the measure of angle 4 will always be greater than that angle 2, and it will always be also greater than angle 3. Okay? And then on the next card, there's one more idea, which is about possible side lengths of triangles. And it's that the sum of any two sides of a triangle must be greater than the third side. Alright, so put your last name and 2 out of 2 here. So if we have this triangle ABC, what this means is that in order for this to be a triangle, AB plus BC must be greater than AC, AB plus AC must be greater than BC, and BC plus AC must be greater than AB. If all of those things are true, then we're allowed to, this triangle is allowed. Okay? It's impossible to draw a triangle without these three things true. So let's see how to use those. Okay? Let's see. 1/4/2013. So start with your heading. And now we're on G.G.31 point. The first problem is 168. Okay? So let's write down the problem. Side segment PQ of triangle PQR is extended through Q to point T. Which statement is not always true? Okay? And then we have 4 choices. 1 is that the measure of angle RQT is greater than the measure of angle R. Choice 2 says the measure of angle RQT is greater than the measure of angle P. Number 3 says that the measure of angle RQT is equal to the measure of angle P plus the measure of angle R. And then number 4, the measure of angle RQT is greater than the measure of angle PQR. Okay? So, let's draw a picture of this. We have triangle PQR and side PQ is extended through Q. So here's how I'm going to draw this triangle to make it as easy for us as possible. We have one of the sides of the triangle is extended. So I'm going to make this side the extended side. And it says is extended through Q to point T. So then this is Q and this is T. And side PQ is the one that's extended. So I have to put the P over here. So this is side PQ, and it's extended through Q to point T. So here's our exterior angle. Alright? So if this is P and this is Q, then this has to be R up here. Okay? So, which statement is not always true? The measure of angle RQT, that's this exterior angle right here, is greater than the measure of angle R. Remember, that has to be true. Okay? The exterior angle is always greater than these two non-adjacent interior angles. So it's not that one. Then we have the measure of angle RQT is greater than the measure of angle P. Well, we know that is always true, okay, for the same reason. The measure of angle RQT is equal to the measure of angle P plus the measure of angle R. All right, we know that's true from our theorems we just went over. So the choice must be 4, but let's see what it says. The measure of angle RQT is greater than the measure of angle PQR. PQR. And in this triangle it is, but it doesn't always have to be. Okay, I could have drawn this diagram in a different way, where angle PQR would have been greater than angle RQT. So the answer to this one is 4. Okay? Let's put our heading. And this is G.G.32.169. Okay? In the diagram below, triangle ABC is shown with segment AC extended through point D. If the measure of angle BCD is 6x plus 2, the measure of angle BAC equals 3x plus 15, and the measure of angle ABC equals 2x minus 1, then what is the value of x. Okay? Now we have four choices. Number 1 is 12. Number 2 is 14 and 10/11. Number 3 is 16. And number 4 is 18 and 1/9. Okay? So, and they also give us a picture, so I'm going to show you what that looks like right now. Okay, the picture goes like this. Okay, this line comes out like that, and extend this line actually a little further, and then this comes like that. That's what the picture looks like, and it's labeled A, B, C, and they have D out here, and there's an arrow on the line. Okay, so let's label this first. AC is extended through to point D. So the measure of angle BCD, that's this exterior angle, is 6x plus 2. Okay. The measure of angle BAC, that's this one over here, is 3x plus 15. And the measure of angle ABC is 2x minus 1. Okay. What is the value of x? Well, if you remember, our first theorem about exterior angles says that the exterior angle is equal to the sum of the two non-adjacent interior angles. So this 6x plus 2 is equal to 3x plus 15 plus 2x minus 1. And they want us to solve for x. So I'm going to write down that equation. 6x plus 2 equals 3x plus 15 plus 2x minus 1. So let's leave the left side alone for a minute and just work on the right side. We have a 3x and a 2x, that's 5x. And we have a positive 15 and a negative 1, that's plus 14. Okay, now I'm going to subtract 2 from both sides, and I get 6x equals 5x plus 12. Then I'm going to subtract 5x from both sides, and I get x equals 12. So there's my answer. Let's just check this. That's what they're asking us for. What is the value of x? So it's 12, choice 1. Okay? Now, what we want to do is do a check. Okay? So here's our check. We had 6x plus 2 equals 3x plus 15 plus 2x minus 1. Let's substitute 12 in for everything. 6 times 12 plus 2 equals 3 times 12 plus 15 plus 2 times 12 minus 1. All I did was plug a 12 in for all my x's. Okay, 6 times 12 is 72, so we have 72 plus 2 equals 3 times 12 is 36 plus 15 plus 2 times 12 is 24 minus 1. 72 plus 2 is 74, and then 36 plus 15 is 51 plus 24 is 75 minus 1 is 74. So it checks. Okay? So that's it for this problem. Let's do the next sheet. Let's put our heading. and this is G.G.31.170. In the diagram below, of triangle ABC, side BC is extended to point D, the measure of angle A is X. The measure of angle B equals 2x plus 15. And the measure of angle ACD equals 5x plus 5. Okay. In fact, I'm going to write that on the next line because it didn't quite fit here. So, and the measure of angle ACD equals 5x plus 5. Period. What is the measure of angle B? And we have four choices again. We have 5, we have 20, we have 25, and we have 55. Okay? And we have a diagram also. And this is what our diagram looks like. Okay, we have a flat line like that, and this line goes like this and comes back in kind of like that. So we have that triangle with this extended angle here, and let's label this diagram. They have it as D, A, C, and B. Okay, and this is exactly the problem that's given to us. So, in the diagram below of triangle ABC, you can see triangle ABC right here. Side BC, here it is extended to point D. So here's our exterior angle. The measure of angle A is X, so this one is X. The measure of angle B is 2x plus 15. Okay? And the measure of angle ACD, that's our exterior angle, ACD, it's this one, is 5x plus 5. Okay? So we're going to solve this the same way. The exterior angle is equal to the sum of the two non-adjacent interior angles. These are all interior angles. This one is adjacent. These two are non-adjacent. They're not next to it. Okay? So, let's set up our equation. 5x plus 5 equals x plus 2x plus 15. So let's leave the left side alone for now because it's already simplified. Let's combine the x and the 2x on the right side to give us 3x, and then we have plus 15. So we've already combined all the like terms on both sides of the equation. Now I'm going to subtract 5 from both sides. So I get 5x equals 3x plus 10. Now I'm going to subtract 3x from both sides. So I get 2x equals 10. And now I'm going to divide both sides by 2. and I get x equals 5. Okay, and that's choice 1. Now let's do a check. Write down the equation, the original equation. 5x plus 5 equals x plus 2x plus 15. Let's plug a 5 in for all our x's. So we have 5 times 5 plus 5 equals 5 plus 2 times 5 plus 15. So 5 times 5 is 25, so we have 25 plus 5 on the left. And on the right we have 5 plus 2 times 5 is 10 plus 15. So let's go back to the left. 25 plus 5 is 30. And on the right side, 5 plus 10 is 15, plus 15 is 30. So it checked. Okay? This is the measure of angle B. Angle B is 2x plus 15. So all this work is correct. I found x and I checked to make sure my x is true. I got to go back, and of course they put that down as an answer. Okay? Now, let's fix this. So the measure of angle, where is it? B equals 2x plus 15. So the measure of angle B equals 2 times 5 plus 15. So the measure of angle B is 10 plus 15. The measure of angle B is 25, and that's degrees. So there is my answer. Now, let me just make sure none of the other ones were like that. Next problem. G.G.31, and now we are on 171, so point 171. And here we go. In the diagram of triangle KLM, below, the measure of angle L is 70. The measure of angle M is 50. And segment MK is extended through N. What is the measure of angle LKN? Okay, so that's the question. This is a multiple choice problem. There are 4 choices. The first one is 60 degrees, then we have 120 degrees, then we have 180 degrees, then we have 300 degrees. And here's the picture that they give us in the problem. Okay? We have this triangle just like this, and they have this is L, this is K, and this is M, and then the extended side MK straight out, and they put an arrow here and they put a point N right there. So in the diagram of KLM, triangle KLM, the measure of angle L is 70, so this is 70 degrees. The measure of angle M is 50, so this is 50 degrees. And segment MK is extended through to N. What is the measure of angle LKN? LKN. This is our exterior angle. Let's put it as X. Well, we know that this is equal to the sum of the exterior angle is equal to the sum of the two non-adjacent interior angles. So, X equals 70 plus 50. X equals 120 degrees. Well, let's make that a 70 degrees plus a 50 degrees. And that's it. So this choice is 2. And we don't have to check that because it's just 70 plus 50. Okay? That is the end of that problem. And this is G.G.32. Okay? Let's write it down. In the diagram below, of triangle BCD, side DB is extended to point A. Which statement must be true? Okay, so they give us 4 choices. The first one is that the measure of angle C must be greater than the measure of angle D. Then we have the measure of angle ABC is less than the measure of angle D. Try to make those angle signs look a little better so we don't get them confused with the greater or less than signs. This is a less than, this is a greater than. This is an angle sign. The angle signs usually come down at a slant, touch the line, and then go straight to the right. And you can see the difference between the greater than and the less than signs, how they're in the middle. And they're 2 angles. Okay, so be very careful with the difference between those 2. The third choice is that the measure of angle ABC is greater than the measure of angle C. And the fourth choice is that the measure of angle ABC is greater than the measure of angle C plus the measure of angle D. Okay? And we have a picture for this one. And it says which statement must be true. So let's draw the picture. Let me use a little ruler this time to make it a little easier for myself. We have a line, goes like that. And they have a point over here. This is A. Then they extend this line kind of like this. Okay, and then they bring this line back towards this other line like that. That's what we have. And they label this C, B, and D. So this is an exterior angle problem, just like the rest. Alright, this is similar to the first one we did now. So here's our exterior angle, ABC, right? Let's look at the first one. Which statement must be true? The measure of angle C is greater than the measure of angle D. Well, that doesn't have to be true. Okay, nothing tells us that that has to be true. It could be true, but it doesn't have to be. So it's not that. The measure of angle ABC is less than the measure of angle D. ABC, this angle here, the exterior angle, must be greater than the two non-adjacent interior angles. So it's not that one. That one's false. The measure of angle ABC is greater than the measure of angle C. That's the answer. It must be. That's one of our theorems for exterior angles, that the exterior angle is greater than both of the non-adjacent interior angles. So it's got to be greater than C, and it has to be greater than D. So we know number 3 is true. And then number 4, the measure of angle ABC, just to take a look at it, is greater than angle C plus angle D. Actually, it's exactly equal to angle C plus angle D. That's one of our other theorems. So remember, the exterior angle is equal to the sum of these two. That means it must be greater than both of them. So it's not 4, it's choice 3. Let's go to the next one. This is G.G.32.173. Okay, here we go. In the diagram below, of triangle ABC, BC is extended to D. Alright. If the measure of angle A is x squared minus 6x, the measure of angle B is 2x minus 3, and the measure of angle ACD equals 9x plus 27, what is the value of x? Okay, then we have choice 1 is 10, choice 2 is 2, choice 3 is 3, and choice 4 is 15. Okay? Now, they also have a picture for this one, so let's draw in the picture. I'm going to make this a little bigger. Hopefully we could fit. Everything we want to into the diagram. Okay, that's the picture, and they also labeled it B, A, C, D, and they put a little note underneath it that says not drawn to scale. So this is exactly how the problem came to you in the Regents. Now, let's see what they're talking about. So in the diagram below of triangle ABC, that's this triangle, segment BC, here's segment BC, is extended to D. See how it's extended to D? So we form this exterior angle here. Okay, now the measure of angle A is x squared minus 6. Minus 6x. Okay? The measure of angle B is 2x minus 3. And the measure of angle ACD is 9x plus 27. What is the value of x? Okay, well, we know that the exterior angle is equal to the sum of the two non-adjacent interior angles. So 9x plus 27 is equal to the sum of these two. So let's just write that out. 9x, I'm going to move this up a little. We have 9x plus 27 equals 2x minus 3 plus x squared minus 6x. So the left side, it already has all its like terms combined, so I'm just going to rewrite that. And now I'm going to work on the right side. So I'm going to put my x squared first. Okay, we should always put our terms in power order. So x squared will go first. Then I'm going to combine all my x terms. So I have a 2x and a minus 6x. That would be minus 4x. And then all I have left is a minus 3. So here's minus 3. Okay. So now I'm going to subtract 9x from both sides. This is a quadratic equation, folks. Okay. So that means you got to get one side to equal 0. Alright? Once you see an x squared in your equation and an x term, you're going to have a quadratic equation. So let's review how to solve this. You should know this from algebra, but this is a good review. So on the left, we just have the 27, right? See, I'm going to get all my terms on the left over here so that my left side is 0. Or I could get all the right terms over to the left so that my right side is 0. But it'll be faster for me to do it this way, so this is how I'm going to do it. So I have x squared, a minus 4x and a minus 9x, that's minus 13x, and then I have minus 3. Okay? Now I'm going to subtract 27 from both sides. Now I get 0 on one side, that's what I want. And this is what we do for quadratic equations. Okay, that means that when you have a variable squared. So 0 equals x squared minus 13x minus 30. Okay? Now, if I want to try to factor this, okay, into two sets of parentheses. So what I want to do is factor this into two sets of parentheses. Do you remember this? And I put an x term in the beginning of each one, right? Then I have to think of the factors of negative 30 that add up to negative 13. Okay? So let me list right over here next to my problem. I'm going to list all my factors of negative 30. Okay? In like a T-type chart. Alright, I have negative 1 and 30. I have 1 and negative 30. I have negative 2 and 15. I have 2 and negative 15. And I have negative 5 and 6 and 5 and negative 6. Each pair of these multiplied together to give me negative 30. Okay? Those are all of the factors of negative 30. And now I look at which two add up to this middle number here, negative 13. So I factor the last number, and don't forget about the negative, and I look for which pair of factors adds up to this middle number, negative 13. If I look at my chart, here it is. 2 plus negative 15 is negative 13. So those are my factors that I put in my two bubbles. So I take 2 and I put it here, and I take negative 15 and I put it here. Now this 2 is a positive 2, so I put the plus there. So those are my two. That's how you factor this. Okay? Now if you did this and you didn't find two factors that add up to that middle number, you would have to do the quadratic equation. But that's for another problem, not this one. So now what we do is we break this up into two separate problems. Okay? And the reason is because if we have this, you can think of this whole thing, x plus 2, as one term, and this whole x minus 15 as another term. If this times this is 0, that means one of them has to be 0. So what I do is I take the first one and I set it equal to 0, and I take the second one and I set it equal to 0, because at least one of them has to be 0 for this equation to be true. Now I solve each side by itself. On the left I get x equals negative 2. I keep solving on the other side. So on the right I get x equals 15. So when I work with quadratic equations, I get two answers. Okay? My first one is negative 2 and my second one is 15. Alright, now since we're working with sides here, okay, if I plugged a negative 2, see these values represent the sides of, angles. Okay? And when we work with angles and triangles, they're positive angles. If we plugged in negative 2 into these angles, we would get negative values for some of them. Okay? For instance, if we plugged a negative 2 in over here, it would be 2 times negative 2 is negative 4, and negative 4 minus 3 is negative 7. Okay, you don't work with negative values when you're talking about angles with triangles. Okay? So what we can do, that means, is that we can reject this answer. And so our answer then is 15. And you can see that that's one of the choices here. And you can see that obviously negative 2 wasn't even a choice. Okay? So we also need to do a check for this. Okay? Let's try to fit that in. Right, I'm going to try to fit it in right over here. I'm going to write it a little smaller so that I can fit it in. We have 9x, this is the original problem, plus 27 equals 2x minus 3 plus x squared minus 6x. Okay? So let's plug a 15 in for all their x's. So we have 9 times 15 plus 27 equals 2 times 15 minus 3 plus 15 squared minus 6 times 15. Let me put a little line here to separate our work. Okay. 9 times 15. 9 times 5 is 45, so I put a 5 down, and I carry the 4, and 9 times 1 is 9, plus the 4 is 13, so I have 135 plus 27 equals 2 times 15 is 30, minus 3, plus 15 squared is 225, minus, and then 6 times 15 is 90. Okay? 135 plus 27, that's 145, 155, 162 equals 30 minus 3 is 27. 27 plus 225, that would be 235, 245, 252, and 252 minus 90 is 162. So that works. Okay, you have to check your problems, especially with quadratics. Alright, now let's also check the negative 2 value to see what happened with that one. So let's rewrite. We have 9x plus 27 equals 2x minus 3 plus x squared minus 6x. Now let's plug our negative 2 into all of our x's. 9 times negative 2 plus 27 equals 2 times negative 2 minus 3 plus negative 2 squared. Don't forget to put your negative 2 inside parentheses, okay? Because when you put the negative 2 inside parentheses and you square it, you get 4. But if you don't have the negative 2 inside parentheses and you square it, you get negative 4. That's one of the most common mistakes. So then we have minus 6 times negative 2. 9 times negative 2 is negative 18. So we have negative 18 plus 27 equals 2 times negative 2 is negative 4 minus 3 plus 4, because negative 2 inside parentheses squared is 4. And then we have minus 6 times negative 2 is negative 12, but a minus negative 12 is a plus 12. So negative 18 plus 27, that would be 9. So we have 9 equals negative 4 minus 3 is negative 7, and negative 7 plus 4 is negative 3, and negative 3 plus 12 is 9. So you can see they both even check out. Okay? But we have to reject that negative 2 for the reasons why I stated before. You're not going to have a negative angle when you're dealing with triangles. And if we plugged it into this angle and even to this angle, no, if we plugged it into just this angle, we would get a negative angle. And it is not acceptable. So you reject the one answer and you keep the other answer. Okay, so that's problem 173. Now we're on the next problem. Okay. This is G.G.32.174. Okay. In the diagram below, of triangle ABC, D is a point on segment AB, the length of AC is 7, the length of AD is 6, and the length of BC is 18. And the question, well, the statement is that the length of segment DB could be, and then it gives you 4 choices: 5, 12, 19, and 25. Okay, and it has a picture of a triangle. Okay, has this labeled C, A, and B, and it has D right about here. Okay, so it says AD, which is the length from A to D, is 6. It says AC is 7, so that's that side, and it says BC is 18. Now this is labeled in the figure in the problem. Okay, this is exactly how they give it to us. Now, this is in the topic on, this was organized into the exterior angles of triangles, which is G.G.32, but this actually doesn't have anything to do with the exterior angles of triangles, but since it was in this problem set, I included it in here, okay? So I remember when I talked about it at the beginning, it's the possible side lengths of triangles, all right? And it's that the sum of any 2 sides of a triangle must be greater than the third side. Okay? So, let's use that rule to figure this out. They want to know what dB could be, so let's put an X there. Okay? So the lengths of any 2 sides of a triangle must be greater than the third side. So, AC, in other words, let's write this right into numbers. We're not even going to... Okay, we're not even going to do the letters first. AC, 7, plus CB, 18, must be greater than the third side, which is 6 plus X. Okay? So, 7 plus 18 is 25, and that must be greater than 6 plus X. Then we can subtract 6 from both sides, and we get X must be less than 19. So we know that it can't be 19 and it can't be 25 based on that. Okay? But I'm not done now. So what I did was I added these 2 sides, and I said it must be greater than the third side. Now I have to do that same thing for all the other combinations that I have. So in other words, 7 plus, now in the first one I did 7 plus the 18. Now I have to do 7 plus the 6 plus X side. And that must be greater than the third side, which is the 18 this time. 7 plus 6 is 13, so we have 13 plus X is greater than 18. Subtract 13 from both sides. X must be greater than 5. So right now we know our answer because it must be less than 19 and greater than 5. So the only answer is 12. So choice 2. But let's go and also try our last combination here. So we used 7 both times. Now we got to use the other 2 sides. So now we'll do 18 plus 6 plus X. And that must be greater than 7. That's the last combination that we didn't try yet. 18 plus 6 is 24, so 24 plus x must be greater than 7. Subtract 24 from both sides, and x must be greater than negative 17. Okay, well, in this one we already said x had to be greater than 5. Alright, and if x has to be greater than 5, then no matter what, it's greater than negative 17. So this didn't really help us at all. Okay, so our answer is choice 2. That's how you solve that problem. Okay, and we have one more in this set. Let's do it. G.G.31.175. Oh boy. Okay, hang on a sec. Change that 1 to a 2. This is G.G.32. Whoops. These are both supposed to be 32s. So let's fix that. Change this to G.G.32. We're just going to fudge it a little bit. Yeah, G.G.32. These are all G.G.32 problems. So let me go back in my sheets here and fix that real quick. I don't know if I did it for all of them or not. I did it for this one though. G.G.32.174. Yep, I did it for this one. G.G.32.173. G.G.32.172. Oh, I think I did it for all of them. G.G.32.171. G.G.32.170. I didn't do it. I did this one right. G.G.32.169. I did this one wrong. How do I do the first one wrong and the second one right and all the rest of them wrong? Anyway, G.G.32.168. Alright, I'm back on track now. It only took 30 seconds. So this is G.G.32.175. Okay, so here we go. In the diagram below, of triangle HQP, side HP is extended through P to T, comma, the measure of angle QPT, the measure of angle QPT equals 6x plus 20. The measure of angle HQP is x plus 40. measure of angle PHQ equals 4x minus 5. So we want to find the measure of angle QPT. And they give us this picture. So I'm going to draw down here on the leftish side. Alright, so I'm going to go right about there. Should be long enough. Just a little bit off of this. Make it look a little bit more like the picture. It even goes like that. Okay. This is what the picture has, plus it gives us some labeling here. Q, H, P, T. This is labeled as 6x plus 20 in parentheses degrees. Then it has x plus 40 in parentheses degrees, arrow pointing to this angle. And this one is 4x minus 5 in parentheses degrees for this angle. Okay? And it also says not drawn, so sometimes they write this, sometimes they don't, not drawn to scale. Okay, so, well, this is a classic exterior angle problem, right? The exterior angle is equal to the sum of the two non-adjacent interior angles. So we have 6x plus 20 is equal to x plus 40 plus 4x minus 5. So we have 6x plus 20 equals x plus 4x is 5x, and 40 minus 5 is plus 35. Then we can subtract 20 from both sides. So we get 6x equals 5x plus 35 minus 20 is 15. Subtract 5x from both sides, and what we get is x equals 15. Now there's no choices on this one. This is not a multiple choice problem. Okay, this is one of the part 2, 3, or 4 problems. So we found x, but let's see what they're asking us for. They're asking us for the measure of angle QPT. QPT is 6x plus 20. So we have to plug x back in. So the measure of angle QPT equals 6x plus 20. So it's equal to 6 times 15 plus 20, which is 6 15s is 90 plus 20. So it's equal to 110, and that's got to be degrees. So let's just bring down this measure of angle QPT part. And let's box off our final answer. Now we have to be very careful with these types of problems, because sometimes it says find x, and then we would be done here. But other times it will say oh, find, the angles, then we have to plug the x back into whatever angle they're asking us for and find that. Now that reminds me, one of the problems we did that, and I don't know if I did it